see them.
Hmm?
I'm going to the campus today.
You're going to see them?
I'm going to be at North Central today.
You're going to be at North Central today. Why?
Volleyball.
Volleyball. Are you playing against them?
I am not.
You are not. All right. All right. There are right now 3 different formulas that you need to know in order to find derivatives. 3 formulas. What are they? What are they? Celeste, give me one.
The limit as h approaches 0 of f(x plus h minus f of x over h.
Okay, limit as h approaches 0, f of x plus h minus f of x all over h. This guy here is going to give you the derivative at every point. Ooh, every point. Your final answer is going to look like a function of some sort. I love working with this one because then you get a function and I say, what's the slope at 2? You can use the answer. What's the slope at -3? You can use the answer that you get from here. That's one formula. There are other ones. There's 2 more that you need to know and know well. Aaron?
The limit as x approaches a
Limit as x approaches a,
equals f of x minus a.
f of x minus what?
F of a.
Minus f of a, thank you.
Over x minus a.
Over x minus a. And this guy here, this one starts off as like slope of secant. And when you throw on that limit, what you're going to get is slope of tangent at x equals a. Okay? So this is going to tell you derivative at one point. And sometimes this guy is advantageous. Sometimes you're going to want to use this one. It's a little easier to work with. But the problem is if I change the point, if I say, what's the slope of the tangent line at some other point, you got to repeat the whole process. And that's a pain. I'd rather go with this one. There's one more formula, and I've not made a big deal of this with the A, B, or BC students before you, but the College Board has changed their expectation. There's one more formula. It's the one we talked about yesterday. It's like a hybrid of these 2. Lewis, what's the other one?
Limit as h approaches 0.
Limit as h approaches 0.
F of a plus h
F of a plus h
minus f of a
minus f of a
over h.
over h. What you're going to get is the derivative at one point. Okay? It's just like this guy here. The limit as h approaches 0, f of x plus h minus f of x all over h. What's different is instead of saying like at any value x, we're doing it at a specific value of a. This one is not one that I use a lot. I'm most likely going to use one of these 2, but don't be surprised if this one shows up. Okay, this is just one of those, like 95% of the work we're going to do is up here, but this one's going to show up. You know, like Friday at your test. But anyway, enough about that. Enough about that. All right, so excited. So excited. We've done our limits, we've done our derivatives. Today we get to focus on word problems. You guys are gonna write till your hand cramps. Oh, so good. I want to talk about, though, life before you met me and life since you've met me. Giselle was smiling a lot. Life before you met me. Oh, life was good. I saw you. All right, way back in the day, like think like Mr. Kerr, think Mr. Link. We would look at a function. We would pick 2 points on the function. We would connect those 2 points with a line. What kind of line is that red line?
Linear.
A linear line. A secant line. All lines, Celeste, would be linear. It's a secant line. David, how do you know it's a secant line? That line is passing through 2 points. Technically, if you think about this line going on forever, you're going to be like, no, there's a 3rd point. Let's just consider this a segment that has a starting point and an ending point. We found the slope forever. You know that the way that we find that slope, well, what do we do? How do we find slope? You guys probably remember rise over run, right? Like what you do when the bell rings, you rise and you run. Okay, you don't run and then rise, that would be awkward. You have to rise before you run. Good, see? You also might remember y2 minus y1 over x2 minus x1. You might remember this as change in y over change in x. You might have looked at this as f of b minus f of a over b minus a. These all familiar? And you guys used to call that AROC. AROC for average rate of change. Average rate of change?
We have,
I think it's was done.
No.
Maybe you never called it AROC. Okay, well if I was your algebra 2 teacher, we would have called it AROC. Average rate of change. And there was this sentence, and I will tell you, it showed up in pre-calculus on every semester exam. I know because I wrote them. You always had to explain the meaning of the answer. You had to explain it, and I'll tell you, you guys are not very good at it. What you had to say is you have to say something like from x equals a to x equals b. I'd want to see something like the function is, and then you would either say increasing or decreasing. Increasing or decreasing at an average rate of some number, and then it's like the units for the dependent variable over the units for the independent variable. From x equals a to x equals b, the function, whatever the function is measuring, is increasing or decreasing at an average rate of whatever number you get from the slope, units for the dependent variable over units for the independent variable. That was the sentence. That was before you guys met me. Now, life is good. Life's real good, Giselle. We don't need 2 points anymore to find slope. We can do that if we just have one little point and one special line, and we're going to call this special line A. We're going to call it a tangent line. And for tangent line, we've already got all these different formulas. I want to show you guys some different notation for slope of tangent line. You know one of them already. Notation for instantaneous rate of change. Notation for slope of tangent line. What do we got out there? We've got tan. Tan at x equals a. That's one of them. Yep.
What's the name? Like f of x, like f prime of x.
You've got, I'm going to call it f prime of a right now, like the derivative at x equals a. There are others that are coming. We're going to write dy dx, which might make you think a lot of like delta y over delta x. dy over dx means derivative. But we're going to say derivative at x equals a. We might even have f prime of x at x equals a. If you want to go to the land of India, they might use f dot. This is actually, I'm not making a joke. It's actually a thing.
yes, I agree with you.
Now, I'm not being culturally insensitive, I'm being culturally appropriate. It is notation that all my Indian professors used. They wouldn't use derivative, they would use like f dot.
Oh yeah.
Okay? Which just meant derivative. Everybody okay? Aaron, stop thinking those thoughts. I can hear them. All right, so we've got all the different notations. Now here's the sentence. The sentence is going to change in one way. Because we're talking about instantaneous rate of change, you are no longer going to tell me this interval nonsense. You're not going to say from x equals a to x equals b. We're going to change it to talk about an instant. So at x equals a. All your sentences will be at x equals a. Let's finish the sentence. The function, what's it doing?
It's increasing.
Is increasing or decreasing. Is everybody okay? We're going to have to like decide increasing or decreasing.
Mm-hmm.
Myra, how are you going to decide increasing or decreasing?
It's decreasing if the function is less than 0.
Ooh, close, you get all the pieces. If the derivative is less than 0, we're going to say decreasing, and if the derivative is positive, we're going to say increasing. So at x equals a, the function is increasing or decreasing at a rate of, give me a number, and then it's the units the same way. The units for the dependent variable divided by the units for the independent variable. Everybody mostly okay? You get this under control? Good. All right, so with that said, I need some water. I want you guys to get an opportunity to try this here. Okay, top of page 56. There's an Algebra 2 question that I want you to see what you can do. You get about 2 minutes for the Algebra 2 version. Steven, how are we doing with the camera this morning?
Good.
Okay.
It's not recording.
It is recording, right?
Yes.
It does not sound.
Oh, just checking. Just checking. Good to know. I went with a daring, bold move here. Stripes. That's what happens when you go to YouTube and you see all the videos at the same time, and I'm like, 11 days in a row, solid polos. Change it up a little bit. Might even go wild and wear orange. From 1952, 1960.
Right, you know, like from 10, like changing like this 10 years. So my was like 1/5 or something.
All right. Just to make sure we're all on the same page here, negative 0.2 or negative 2/10. Not negative, not negative a half.
I was looking at this.
All right, I need a brave soul. What's your sentence? From start to finish. I see Lewis looking for a whole lot more brave souls. I see Celeste. What's the sentence that you're going to write, David?
From T equals 1950
From T equals 1950
to T equals 1960,
to T equals 1960.
the function is decreasing.
But let's be specific. What's the function here? What does the
Oh.
function represent?
Non-efficient.
The, what's the function? What are we measuring?
Fish export
The fish export. Tell me more about the fish export, David.
per year.
The fish export, I want to be careful. The function, like the dependent variable is like fish export. The fish export, what's happening to the fish export
It's decreasing.
is decreasing. How did you make that decision, David?
When I have a negative,
Because you have a negative over there. Okay, decreasing, give me more.
at an average
At an average rate, yep.
rate of negative 0.2
Average rate of negative 0.2.
of fish export per year.
Thousands of metric tons.
Wait.
We need units here.
Oh,
What are the units? Celeste, help them out.
I was gonna ask a question.
Hold on, there's also something here I don't like, but let's focus on the units for a second. Stephen, what are the units?
Thousands of metric tons.
Thousands of metric tons. Thousands of metric tons. Those are the units for your dependent variable, now divided by the units for your independent variable, year. Okay, now, with kindness, David needs a little bit of direction here. There's something that I don't love about this sentence, and I see 3 people in the back that see it. There's something wrong with this sentence. Aaron sees it now. Look at the sentence, it's not on my face. What's wrong with this sentence? Oh my God, it's all 4 of them now. It's like a power play back there. Andrew, what's wrong? decreasing, you've already used your negative one time. You don't use it again. You're not decreasing at a negative rate, you're decreasing at a rate of 0.2 thousands of metric tons per year. We're good? We're good. Now my question for you all is, could you find the slope of the tangent line at 1955? Could you find the slope of the tangent line at 1955 in this situation? Have a quick conversation with somebody near you. What do you think? Could you find the exact value at 1955?
We're at 15.
Could we find the exact value at 1955? The answer here has to be, Aaron says of course. The answer is no.
Wait, you don't have a function?
You cannot find the value of the derivative at 1955 polynomial y.
Because when we're solving it, you need 2 points, not just one.
If I want slope of tangent line at one point, how does it work? You need another point, and you let that other point get close, which means I would need an equation. I cannot find the slope of the tangent line at 1955. Are we okay with this? Could we estimate it though? Could we estimate the slope of the tangent line at 1955? Yeah? Polynomial one. What would you do?
Well, we basically the limits as it approaches 1955.
But that still requires you to have a function. And you don't have the function. If I asked you to approximate the slope at 1955, don't overthink this. The tangent line is what you want. You want the slope of the tangent line. But that requires getting a point wicked close to 1955. We don't have that right now. What you do have though is you have this point over here at 1950. What if you found the slope between those 2 points?
Pretty cool.
That would give you an approximation, because what you'd be using is a secant line approximation.
Yes.
Okay? Somebody else might say, well, what if I want to use these 2 points? Is that okay? Yes, it's okay. Because what you're asking to do here is you're approximating the slope of the tangent line at that point. Everybody okay? All right, let's move on. Let's do some calculus. Myra, can you read the AP calculus version of this question?
Let p of t equals 60 minus 3 square root of t represent a continuous function which can be used to approximate the data in the table above, where t measures a number of years since 1940 and p of t represents the number of metric tons measured in thousands of fish produce exported that year.
Yep.
Using correct units, explain the meaning of the instantaneous rate of change at t equals 16.
Okay, have a quick strategy conversation with somebody near you. What are you going to do now? How are you going to find that instantaneous rate of change?
You can use this one, but this one is that
But
one.
it's gonna be great.
Well, you can
Because
put
then
two
you
know what,
would
just get it.
find this and
Wait,
write
no,
the
it's
function, and then you would have to put it
So what do you guys want to do? How are we going to figure it out? Oh my God, you're dying on me. Oh my God, everyone's dying on me. What are we going to do? Giselle suggested using tan. Tan. I think I agree. All right, so I think most of you guys have come to the conclusion that what we want to do, I heard David say, Giselle suggested tan at x equals 16, and I'll tell you, I like it, I don't love that. T equals 16. Let's be specific and use the right variables. For those of you that want to use some fancy notation, you might be tempted to say f prime of 16. No, not f prime of 16, Aaron. Why not f prime of 16? Well, we are looking for a derivative. I'm looking for instantaneous rate of change, but why not f prime of 16?
Oh, it's E.
It's E. I am that picky, Polymon. I want E prime of 16. Hopefully, this next part is relatively easy. Right, so like feel free to finish this off on your own. You want the limit as t approaches 16, e of t minus e of 16 over t minus 16. Oh, annoying little brother, gotta carry him all the way through, God bless.
Thank you.
60, oh, it was you, never mind then. E of 16, parentheses, need those parentheses. Need to simplify. 60 minus 3 square roots of t. Square root of 16 is 4, times 3 is 12. Subtract that from 60, what is that, 48?
Yes.
Okay. I like that. Gotta keep going. Limit as t approaches 16, 60 minus 48, 12 minus 3 square roots of t over t minus 16. Celeste, what are you gonna do? How are you gonna evaluate this limit? I mean, Carmen, sorry.
Multiply by the conjugate?
You can multiply by the conjugate, which is always a thing to do when you see the square roots. That's a good thing. I have another idea for you. And if this does not work, if this doesn't fit in the brain, it's okay. Is everybody okay? Multiplying by the conjugate would work?
Yeah.
Okay. Because I see the square root of t in the numerator, because I know I'm getting 0 over 0, that indeterminate form, I want to look at t minus 16 a different way. If it was t squared minus 16, would everybody be able to factor that?
Yeah.
Because it's like difference of squares. T minus 16 is a difference of squares as well. 4 squared is 16. What squared is t?
Oh,
Square root of t.
How about square root of t? Maybe not an obvious thing, okay? But look what happens if you do this and you do it right. Now you've got the limit as t approaches 16. 12 minus 3 square roots of t, the denominator, is the square root of t minus 4 times the square root of t plus 4. And at first you might be like, why would I bother doing that? Check out the numerator. In the numerator, I've got a common factor of a 3 that I can pull out. And just for the sake of time here, I'm going to pull out that 3. And that leaves me 4 minus the square root of t. One of the things I keep seeing though on the quiz where we're making some mistakes here, 4 minus the square root of t, square root of t minus 4, these cancel.
Oh, so
No.
negative
They
3.
cancel, but they are opposites of one another. Positive 4, negative square root of t, negative 4, positive square root of t. You can cancel, but you have to cancel, and it leaves behind a sign of a negative 1, because they're opposites of each other. Imagine 5 divided by negative 5. Negative 10 divided by positive 10. They cancel, and it leaves a negative behind. So your final limit, Lewis, you're staring at me in a way that's a little scary right now. It's very intense. If you didn't see that factoring difference of squares, multiply by the conjugate, same thing. Final limit answer.
No. Wait.
What'd you
Four.
do?
Oh, negative 1 over 8. Wait. Oh,
Lewis,
wait.
was that what that really intense stare was for? Okay, I should stop. And Lewis is like the conscience on my shoulder. He's like, slow down, big boy. You made a mistake. The striped shirt's messing with the mojo here. Okay, is everybody okay now? What's the final limit?
Negative 3 over 8.
Negative 3 over 8. Okay, take 1 minute. I want the perfect final sentence. No kidding. No high fives. No high fives. Nobody touch me. Trying to adopt a kid. Don't have time to get sick. All right, I don't think you finished with the sentence yet, but that's okay. Get me started on the sentence. What would you say?
At t equals negative, at t equals 16,
At t equals 16,
the metric ton,
tell me about the function. What's the function? Metric tons are the units. What's the function? What is it that we're measuring?
the fish ton,
The fish export. Okay. What's the fish export doing?
is decreasing
Is decreasing.
at a rate
Decreasing at a rate of
3/8.
3/8
Metric tons.
Metric tons.
per year.
metric tons per year. I like it, I don't love it. It's so close. Wait. Oh, yeah. I like it, don't love it. It's so close. It's so ridiculously close.
Metric thousand.
2 people? 3 people?
Oh, obviously.
What's the issue? What's wrong with the units?
It's not thousands.
Thousands of metric tons per year. Myra, that was an awesome sentence. You had all the right pieces. You threw me in the beginning when you started with like a t equals negative something. I'm like, okay. Okay, so the only thing missing is thousands of metric tons per year. We get this under control? Okay, good. All right, so here's what I want you guys to do. Number one, if you guys could grab an index card or a post-it note from the middle of the table. One thing I normally do at this point in the year is I ask everybody for like your alias, your password. I don't want the password to your email account. I don't want the PIN number to your bank account, and 1 card per table is fine. If you could just write your name and then the alias you want me to use when I pass around the grades. Something school appropriate. We don't need Robo-Stud or Hot Dude number 14. Something appropriate so that when the grades come around, you're going to look at it and be like, oh yeah, that's me. David, I think you're like totally overthinking this.
I don't know what's right.
Okay, then pass it around to Myra or someone else. Alright, we are taking way too long. All I need is like Aaron and then your alias. Myra and then your
Write your name and
alias.
then like what you want him to like basically refer to it.
No. I'm not gonna call you this. It's for your grade so that it prints out with like a name next to it that's not yours.
Like what do you want him to refer to you as?
Good golly.
She got like she panicked and threw the index card at me.
I know it was vicious.
Yes. She's like,
Vicious. Alright. I'm going to assume that we have the ability to multitask, except maybe this group over here. I'm not so sure about that. Alright, perfect. I'll take those. Thank you. Alright, if you guys in your handout flip to page 59. Now this means we are skipping past 57 and 58. For the AB students, we'd probably spend about 10 or 15 minutes here. We're going to skip past that part because what I want to do is I want to go to a nice model problem that's going to push the thinking. So in your teams here, I want you to take 2 minutes, read through this problem, make the most out of it, show me what you can do in part A, and be ready to talk about part B. You guys are still working. Okay.
What's mine?
I'm saying that out loud.
It wouldn't be an alias if he said it out loud.
answer. Let's. All right. According to researchers. Oh, that's right. I didn't actually look at researchers. I just made up a function. Okay, we're relating speed of the car to fuel efficiency, which is measured in miles per gallon. So the units for V is velocity. We're measuring in miles per hour. G of V, what's G of V measured in?
G of V is measured in fuel efficiency of the car.
No, but what are the
miles
units?
per gallon.
Which is miles per gallon, right? You probably see the car commercials and they're always like, this car gets an average of like 32 miles per gallon in the city, right? Like that's what we're talking about with fuel efficiency. So part A, compare the fuel efficiency of a car traveling 27 miles an hour to that of a car traveling 50 miles an hour. Well, the fuel efficiency if I'm traveling 27 miles an hour, we need to use first function. So negative the square root of 27 plus 9 plus 32, 36, square root of 36 is 6. What is that, 26?
46.
Not 46. Should be 26, right?
Yes.
Okay, 26 I need units.
Miles per gallon.
Miles per gallon. Miles per gallon. All right, and then G of, what is it, 50? G of 50, I need the other one, so negative 50 minus 40 squared plus 25. That makes no sense. That number makes no sense, does it?
It'll give you negative 75.
So it's 10, you're gonna get negative 75 miles per gallon. Yeah, no sense there.
Yeah, that's totally right now.
Don't look, stop looking, that's bad.
That's fine.
Okay, negative 75 miles per gallon. Clearly, I did not consult with researchers and I have a little bit of work to do here. Let's ignore that, let's move on. Determine the value of G prime of 27. Using correct units, explain the meaning of your answer. I have confidence in this one. Padamon?
Oh, so you just erase the second negative part at the beginning of the equation.
Yeah, that's nice. If you get rid, oh, this one?
Yeah.
So now what you're saying is I'm traveling 50 miles an hour and I'm getting 125 miles per gallon.
It's better than negative.
It's better than negative. Still in the world of impossible right now, and let's move on. This one clearly has some work needed here. Okay? All right, B, G prime of 27. Show me what you can do with that one. G prime of 27. If this was a quiz question, your ability to set up the initial limit expression would probably get you the first point. So I care greatly about doing this. Get the variables right. Don't forget about the annoying little brother. So in a problem like this, I am only going to give you the first point if you're using the right function name. It's got to be G, not F. I'm going to look at the variable. What?
G of V.
G of V. Okay, great. Thanks for making me a better teacher. So it's not T approaching 27. V approaches 27. So G of V minus G of 27 over V minus 27. Is everybody okay? Seriously, thank you for pushing me on this. I want to make sure that what I'm modeling is the right stuff for you all. Don't call me, I'm teaching. Gotta close the achievement gap. Okay, limit as V approaches 27, G of V minus G of 27 over V minus 27. Maybe it was one of the North Central kids calling to let me know I made a mistake. All right, limit as V approaches 27, G of V is this negative square root of V plus 9, plus 32, minus G at 27, we already figured that out, didn't we? 26 over V minus 27. You guys are probably fine without me on this one, so just finish it off. Limit as V approaches 27, negative square root of V plus 9 plus 6 over V minus 27. Looking at what I'm working with here, I don't know that I'm going to try to factor using a difference of squares. It's not going to cancel with what's in the numerator. So I am going to go back to my old favorite, multiply by the conjugate. Negative square root V plus 9 minus 6. Negative square root V plus 9 minus 6. If I do the limit, it's the limit as V approaches 27. Multiply out the numerator. Negative square root of V plus 9 times negative square root of V plus 9. Is that positive V plus 9? Negative square root of V plus 9 times negative 6 gives me a positive 6 square root of V plus 9. 6 times negative, those guys cancel out. They're always going to cancel out if you multiply by the conjugate. Positive 6 times negative 6, negative 36. In the bottom, V minus 27 times negative square root of V plus 9 minus 6. Is everybody okay with the simplification? Is this working? Okay, and if you guys are okay, I want to save myself a step here. V plus 9 minus 36 is really V minus 27. V minus 27 in the numerator, V minus 27 in the denominator. They're going to cancel. So we've got the limit as V approaches 27 of 1 over negative square root of V plus 9 minus 6. V gets close to 27. What's this final limit? V gets close to 27. Not negative 12.
Negative 12.
Negative 1 over 12. Okay. Is everybody okay getting to negative 1 over 12? Okay. Get me that final sentence. What does this mean? And Myra, since you did the last one, you get to pick somebody who's going to read their sentence. But don't say it yet. Make them all sweat. I saw her looking at you. I think you're terrible. All right, Myra, pick your victim. See how she rolls like that? All right, Adelaide, get me started.
At V equals 27,
At V equals 27, what do you know?
the fuel efficiency of the car
The fuel efficiency of the car.
is decreasing
Fuel efficiency of the car is decreasing
at a rate
at a rate
of
of
1 over 12
1 over 12. Now here comes the tricky part. Think of it as a fraction. What you got?
miles per gallon.
Miles per gallon
Miles per hour?
over miles per hour.
Oh.
Those are some ugly units, but the
Yeah.
correct units are miles per gallon over miles per hour. Those would be the right units there. Nice job. Nice job. How we doing? Okay. All right, part C, determine the equation of the tangent line to G when V equals 27. Okay, equation of tangent line, I need two things. Two things, I'm always gonna need the same two things. Andrew, what are the two things you need for the equation of the line, tangent line? Oh, keep it even easier than that. You want the equation of the line, two things. Oh my God, even easier than that. You want the equation of a line, you need two things. Point, slope. Yeah, yes, both of those things. Point, slope. When V equals 27, the coordinates of the point are 27 comma what?
27,
What's the y value? 26. What's the slope? -1/12. The equation of the tangent line? Put those together. And I'm going to call it not L of x, but L of t, because t is my independent variable. It is going to be -1/12. V! Damn it! V minus 2. I mean, thank you for making me a better teacher. All right. Kids these days. Can't wait to grade your tests on Friday. I said make you better students, that's right. All right. We're good.
What do you have?
Okay, good. Yeah, because I want to know about it.
I think I want to eat peanut butter.
I almost think something
In the moment I was like, my continuity, I'm ready for continuity.
Good, you're prepared. This class we need to review just this last module.
Yeah.
Just to like get the relative magnitude down.
Are you okay with doing that? And with you going?
Yeah, because I did that with my
And how the other class do that?
okay. There's a lot of talking this is what time.
I will leave it. I'll read it tomorrow.
Okay.
I'll leave it. Oh, wait, I was like, no, I need it.